Good morning, grade 10. Good morning, Margie. Okay. So I have only Margie in my class. Your attendance already recorded. Let's move now to fourth quarter. Module 1, this is weeks 1 to 4, right? So to begin with, this is actually gas laws. So in gas laws, this is how we actually compensate the concepts of gases. So how these gases affect us and how these gases also are actually maximized for our use, right? Let's take a look at this one. By the way, Margie, are you the only online student? The rest are already offline? Margie, I will talk to your advisor in regards to this. Gas laws. So let's take a look at this one. All right. Gas laws are examples of scientific laws. When you see scientific laws, these are statements that describe, summarize, and predict some aspects in nature. Okay? So if it is actually scientific laws, it explains nature, some aspects of nature. Or, shall we say, a natural phenomena. Okay? Scientific laws are strongly supported by empirical evidences, which are repeatedly verified with no contradicting observations, number one. Number two, these can be mathematically formulated in one or several statements or equations, number two. And number three, are constant because they summarize what have been observed. So how can we formulate this one? Scientists formulated this one because of constant observation. Laws are different from theories or theoretical. Is it theoretical? A scientific theory, a scientific theory is a well-substantiated explanation of some aspects of natural world based on a body of facts that have been repeatedly confirmed through observation and experiment. Okay, scientific theory may alter or evolve if new evidences are discovered. While laws, these are what? These are natural phenomena, observable natural phenomena. If scientists observe that there are some natural phenomena happening and it cannot be changed, therefore it is actually a law. They will formulate a law or scientific law. Boyle's law. Boyle's law is talking about pressure and volume. What's with Boyle's law? Okay, this is actually formulated by Robert Boyle in 1627 to 1691 by Robert Boyle. Studied the effects of pressure to volume of gas in the sealed end of the tube by adding mercury on an open end. So what is the result with Boyle's experimentation or experiment? He noticed that the volume of definite quantity of a dry gas is inversely proportional, okay, to the pressure provided temperature remain constant. Inversely proportional. When you say inversely proportional, inverse, what does it mean? What comes into your mind when you hear the word inversely proportional? Anybody? How about Demetri? When you say inversely proportional, and when you say inversely proportional, whenever one quantity goes up, the other quantity goes down. That's inversely proportional. Okay? Like for example, pressure and volume. So Boyle's or Robert Boyle is talking about pressure and volume. Whenever pressure goes up, the volume goes down. Whenever the volume goes up, the pressure goes down. And that's inversely proportional. Directly proportional is when when a quantity goes up, the other quantity goes up also. That's directly proportional. Okay. If inversely, meaning the first quantity will go up, the second quantity will just go down because they are inversely proportional. Okay. 1 atmospheric pressure, or ATM, is equal to 760 millimeter of mercury. Okay. We are actually Robert Boyle is actually using the millimeter of mercury. Okay. Or is equal to 760 Torr, named after Evangelista Torricelli, a 17th century Italian scientist who invented mercury barometer. This is the reason why pressure in your gauge in your sphygmomanometer. Are you familiar with sphygmomanometer? Are you familiar with sphygmomanometer? Anybody? Sphygmomanometer is your BP. Okay. They usually term this as blood pressure kits. Okay. We have sphygmomanometers that are automated, meaning to say that it is battery operated, and some of the sphygmomanometers are analog, okay, or with dials, right? So sphygmomanometer, the pressure used there, the units used there is millimeter of mercury. Okay. The normal blood pressure is 120 over 80 millimeter of mercury. Okay. Question so far? Do you have blood pressure kits at home? The aneroid and the digital? You don't have blood pressure kits? Are you familiar with blood pressure kits? How about Margie? Have you seen one blood pressure kit? How about Margie? You didn't actually see one blood pressure kit with the cuff? Not yet? Okay, you wait. Okay, this is one example of a blood pressure kit. Okay, this is the cuff, which is actually um, put in your arm or inserted in your arm. Okay, this is the monitor, BP monitoring. Okay, so if you're going to look at this one, wait, I will just remove my filter. Okay, if you're going to look at this one, right, okay, it, the units used there is millimeter of mercury, Hg. Okay, the systolic and diastolic. So the normal, again, blood pressure, okay, in adult is 120/80. Okay, we actually use this one to measure, again, the blood pressure. Okay, the pressure in your veins, in your arteries, that the heart is actually pumping up. Okay, because Southbrook Boyle discovered that pressure and volume is inversely proportional, he actually what taken the unit millimeter of mercury, and he actually used mercury in that experiment. Do you have any questions so far? Question? Margie and Dimitri? Question so far? Okay, let's move forward. Okay. The pressure and volume relationship can be written as, since this is a law, you can actually use mathematical equations. Okay. P is inversely proportional to B, so T is constant if temperature is constant, or PV is equal to C, where pressure of the gas expressed in mercury, millimeter of mercury, ATM, or atmospheric pressure, or torr, V is equal to volume of gas expressed in milliliters or liters, and C is constant. What is really constant there? Okay. The equation states that the product of pressure and volume is constant for a given mass as long as the temperature is constant. That is actually if the temperature is constant. In comparing some substances under two different sets of conditions, the law can be expressed as, okay, P1 times V1 is equal to P2, pressure 2, times volume 2. Okay, where P1 is the original pressure, V1 is the original volume, P2 is the new pressure, V2 is the new volume. Okay, the kinetic molecular theory explains the inverse relationship between pressure and volume. Okay, if the same amount of gas at the same temperature is confined in a smaller volume, the gas molecules becomes crowded and collide more frequently against the wall of containing vessel, causing increase in pressure. Okay, gas molecules are constantly moving in all directions, thereby creating impact on the sides of the container, and the impact force per unit is called pressure. Okay, so this is now the illustration. As you can see, as volume increase, okay, pressure decrease. One goes up, the other goes down. Okay, as volume decreases, okay, you decrease in volume, you increase the pressure. If the other goes down, the others goes up. That's the inverse relationship of pressure and volume. Okay. Boyle's law explains the following phenomena, or these are the practical applications. So we have in Boyle's law, the bubbles exhaled by the driver increase in size as he or she approaches the surface of the ocean. This is a diver. Okay. The pressure exerted, the weight of water in bubble decrease as one goes up of the surface, hence the size of the bubbles increases. So if you're going to blow a bubble, okay, underneath ocean, you can observe that these bubbles becomes bigger and bigger. Okay. Right. Deep sea fishes die when you go to the surface. This is the reason why those fish living in a deep water will eventually die. The pressure decreases, okay, thereby causing the volume of gas in their bodies to increase in size. This causes membranes of their bladders and cells to pop. Okay, they are not used to it. Okay. An inflated balloon bursts if squeezed too hard. Squeezing reduces the volume of the balloon, thus increasing pressure. And if the balloon cannot withstand the pressure, it will actually burst. So those are practical applications. Syringe. Okay. Syringe. Are you familiar with syringe? Syringe? Everybody, yes. Okay. Syringe is used in drawing blood samples or giving injection. Okay. Your vaccines. If the plunger of the syringe is pulled back, if you're going to pull back the plunger, the volume of the syringe is increased and the pressure inside decreases. Hence, it will actually gather blood. To balance the effects of low pressure, air or blood is sucked into it or through it to the needle. This equalizes the pressure inside and outside the syringe. Air pops at high altitude. Have you tried going in a high altitude, mountainous areas or provinces? Usually your air pops, okay, because of high altitude. Why? Most of the time you feel the pain in your ear while in an ascending or descending plane. Okay. In these situations, there is a pressure imbalance inside and outside your ear. Okay. Increasing or decreasing volume of air inside your ear that strains your eardrum. Okay, to relieve discomfort, swallow hard to equalize the pressure on either side of the eardrum. Okay, when riding an airplane, okay, this is the common scenario: riding an airplane or going in a mountainous provinces, because there is an imbalance pressure, okay, inside and outside your ear. Do you have any questions so far with Boyle's law? This is quite interesting topic. By the way, just to give you a heads up with your project for this school year, okay? Diba, I'm talking about the project for this school year. Right. What I want you to do later on is to create an illustration. It could be a blog, okay? It could be an output, actual output of these laws. Diba, this is just happening everywhere. This is happening in our daily lives, correct? So what you're gonna do is to create a learning resource. When you say learning resource, what do you mean by learning resource? Sure. You say learning resource, this is actually something that explains a phenomena, something that explains a particular science concept. That's a learning resource. So one good example is a blog. It's a learning resource because you're explaining something there, you're giving examples. Second is the actual illustration of a phenomenon. Okay? If you're going to use a blog, okay, you need to explain the different concepts, the different gas laws, because we're talking about gas laws. It should be connected to the topic. It should be gas laws. Right? Am I making this clear? I will just explain this later in the activity part of this module. Am I making this clear? All right. Let's continue with Charles' law. Okay, this is quite interesting topic because this is happening all throughout. We didn't actually notice this one, but this is really happening. Okay. Jacques Charles duplicated the experiment done by Joseph and Etienne Montgolfier and John Ford 1783, known as France. They're actually French. He used to fire, okay, inflate a spherical balloon about 30 feet in diameter that traveled about 1.5 miles before coming back to Earth. So what's with the Charles law? Charles law is talking, or Jacques Charles is talking about the volume and temperature. Okay, what will happen to the volume if there is a sudden rise of temperature? So what is now the relationship between volume and temperature? It was actually answered by Charles. Okay, Charles found out that the volume of gas is directly proportional. Okay. When you say directly proportional, what does it mean? Again, when you say directly proportional, I explained this a while ago. What does it mean? Anybody? How about Margie? What do you mean by directly proportional? What do you mean by directly proportional? Okay, when you say directly proportional, this means that what? When temperature goes up, the volume also goes up because we're talking about the volume and temperature. Okay, Jack Charles is talking about the volume and temperature. Okay, if it is directly proportional, if you're going to heat up this particular volume, it will goes up also. This is how your hot air balloon actually moves or works. Okay, V over T is equal to C. That's the formula where V is the volume of gas, may express in ml or liters. T is the absolute temperature measured in Kelvin. Okay, and C constant. The temperature in which V is equal to 0 is called the absolute zero. Okay, absolute zero is the lowest temperature possible. By international agreement, absolute zero is 0 Kelvin on the Kelvin scale, or negative 273 on Celsius scale. Kelvin is the temperature scale named after Lord Kelvin. This is 1824 to 1907. Each Kelvin is the same size as Celsius degree. Okay, how to change Celsius to Kelvin? You need just to add 273, and then there you go. Like for example, if it is 20 degrees Celsius, we just add 273 to 20, and it will become what? 293 degrees Kelvin. Okay, that is actually how we convert degrees Celsius into Kelvin. Comparing substances, okay, with same pressure under different sets of conditions, the law can express into V1 over T1 is equal to V2 over T2. Okay, where V1 is the initial volume, T1 is the initial temperature, V2 is the final volume, and T2 is the final temperature. Again, the condition, there is a condition here if it is in same pressure. Okay? When a fixed mass of gas is heated at a given pressure, the volume increases because the molecules move faster and expand. Okay? It actually what? If you're gonna heat again certain gas, it will actually increase in volume. So when you put a high temperature, and when there is a rise of temperature, there is also a rise of what? Volume. So that is directly proportional. Okay. Charles' law explains the following phenomena. These are the practical applications that we have with Charles' law. We had hot air balloon. Okay, number one, as the air in the balloon is heated by a small flame, the balloon expands, making it less dense than the surrounding cool air. Thus, the balloon rises. Rising smoke or rising smoke. Smoke is less dense than the surrounding air, hence it rises. Heat from the flame causes the smoke particles to move rapidly, increasing the volume it occupies, thus lowering its density. What else? Swelling of rubber. Slightly inflated rubber, life perhaps slightly swells when left under the sun. So this is the reason why your tire at home, your car tires, need not to be put in a full air. Okay, you need not to inflate it with full air. Why? Because again, when these tires exposed in hot or hot condition, or under the sun, it will actually expand. Once you fill your tires with full air, tendency is what? It will burst in time if the tire cannot actually accommodate the pressure or accommodate the volume of the air inside the tire. Heat from the sun causes gas molecules to move rapidly but apart from each other, thus it actually expands. Okay. Do you have any questions so far? Do you have any questions so far with Charles' law? Okay, let's stop in Charles' law. Let's continue by next meeting. Do you have any concerns as of the moment? Again, as a heads up for your project, this is actually a project. Okay, your project is considered as your performance task. At the same time, this is your output of this school year. You need to leave a legacy in the school. Okay. Remember that this output will be preserved by the school and presented in exhibits if in case. That is why we need to make a good output for this school year. Right? I think that'll be all for today, class. Do you have any questions, reactions? Grade 10? Questions, reactions? Margie and Dimitri, can you hear me? All right. I think that'll be all for today. Have a nice day, grade 10. Enjoy the rest of the day. Bye-bye. Take care.